In this video, we will be doing number 15 in Chapter 4 of the AP Physics textbook on page 102. A projectile is fired in such a way that its horizontal range is equal to 3 times its maximum height. What is the angle of the projection? What is the angle of projection? So basically it's asking for the launch angle. For this one, you want to use the height and range equations. So the equation for height I just looked this up in the textbook. You also should have your notes on these equations. And then for range, so it says its range is 3 times the maximum height. So the way we want to set up our equation is this. And it says the range is 3 times the height. Now what we have to do is solve for theta. So that'll cancel out. G's will cancel out. And I'm going to multiply both sides by 2. So we'll have 2 sine 2 theta equals 3 sine squared theta. I'm going to use my trig identity for this one, where it's that you get a cosine in there. So using that trig identity, you will get I believe that's called the double angle formula, but don't quote me on that. Now you can end up dividing both sides by sine theta, so that cancels out and you'll just end up with sine theta there. So you'll end up with 4 cosine theta equals 3 sine theta. The next thing I'm going to do is divide both sides by 3 and divide both sides by cosine theta. So if you divide both sides by 3, on this side you'll end up with 4/3, and if you divide both sides by cosine theta, you'll end up with sine theta divided by cosine theta. And what's this? Well, that is simply equal to the tangent function. And then you can really easily solve for theta. So if you just take the inverse tan of both sides, you end up with 53.13 degrees. So what this means is that if you want a projectile's range to be 3 times its height, you will launch it, doesn't matter what speed, at an angle of 53.13 degrees.